Imagine your React dashboard grinding to a halt every time you filter or sort thousands of records. If you're building data-heavy dashboards, performance bottlenecks can quickly turn a slick UI into a frustrating experience for your users. Fortunately, there's a powerful tool built right into React that can help you overcome this challenge without adding a single third-party library. In this tutorial, you'll discover how to leverage React's useMemo hook to dramatically speed up expensive list filtering and sorting. You'll learn exactly when and how to use useMemo to keep your dashboards fast, responsive, and scalable, even as your data grows and your UI becomes more complex. By mastering these techniques, you'll deliver professional-grade user experiences, avoid unnecessary re-renders, and reduce technical debt in your codebase. We'll break down the core concepts behind React's memoization, walk through real-world use cases, and provide actionable best practices you can start applying today. If you're serious about building high-performance dashboards with React, understanding useMemo is essential. Don't miss out on future advanced tutorials like this. Subscribe now to stay ahead with proven strategies, practical walkthroughs, and the latest updates every React developer needs. Imagine a massive library where each time someone walks in, the librarian rereads every book to answer the same questions about titles, authors, or genres. This is analogous to how React components behave when expensive operations like list filtering or sorting are performed directly during every render, resulting in wasted effort and sluggish performance. The core concept that addresses this inefficiency is memoization. In React, the useMemo hook is the librarian's notebook, remembering the answers to previously asked questions as long as the underlying books or criteria haven't changed. Instead of working from scratch each time, the librarian checks if the question or the library's contents have changed. If not, the answer is recalled instantly, making operations seamless and efficient. In a dashboard context, this means that filtering or sorting a 10,000-row sales dataset doesn't happen anew on every minor state change, only when filters, sort order, or the data itself are altered. This reduces computational workload and keeps the user experience smooth, especially as datasets and dashboards scale in complexity. Referential equality is a subtle but critical concept when leveraging memoization in React. In JavaScript, arrays and objects are compared by their reference in memory, not by the values they contain. Consider two identical-looking filter objects created separately. They are distinct in memory and thus trigger useMemo to recompute, even if their contents are the same. This is like having two identical keys cut for a door. They look the same, but only the original one fits because it's the actual reference the lock recognizes. To optimize filtering and sorting in dashboards, it's vital to ensure that dependency arrays for useMemo contain stable, primitive values or consistently reused object references from state. Otherwise, memoization is undermined, recalculations happen unnecessarily, and the performance gains are lost. Techniques such as destructuring filter fields or memoizing object creation help maintain referential stability, ensuring useMemo only triggers when true changes occur. This attention to reference ensures that React dashboards remain performant, accurately leveraging the strengths of memoization without being tripped up by the nuances of JavaScript's comparison model. This is the central application file that initializes the dashboard, providing a container and rendering the optimized dashboard component with memoized filtering and sorting. It demonstrates the top-level integration of performance optimization using React's useMemo. This file implements the main dashboard component. It initializes large-scale mock data, exposes user controls for filtering and sorting, and applies useMemo to prevent unnecessary recalculations of expensive list operations. The code demonstrates chaining useMemo for both filtering and sorting, ensuring that each stage only recomputes when its direct dependencies change. This data generation module creates a large array of mock sales data to simulate real-world dashboard scenarios. The generated data serves as the basis for demonstrating expensive filtering and sorting operations optimized with useMemo. The filtering utility provides a pure function to efficiently filter sales records based on product, sales representative, and minimum revenue. It is designed to be used with useMemo to minimize unnecessary recalculations. The sorting utility provides a function to sort sales data by specified fields and direction. It creates a shallow copy of the data before sorting, ensuring immutability, designed for use in a memoized context. This component displays the filtered and sorted sales data in a tabular format. For UI performance, it only renders the first 100 rows, but shows the total number of results, making it suitable for large datasets. The main entry point for the React application. It initializes the root and renders the app component. This test file provides automated integration testing of the dashboard's filtering behavior using React Testing Library. It verifies correct rendering and responsive updates as filters change. This is the project's configuration file, specifying dependencies and build scripts. It uses only React core packages and testing utilities, with no third-party memoization or state management libraries. The page loads and displays the React dashboard memoization demo. As the interface appears, the user scrolls down to reveal dashboard controls, summary cards, and key metrics like total records and total revenue. After a brief pause on the summary cards, attention shifts to the revenue by product chart, followed by a further scroll to the main data table, which renders a large set of records in a tabular format. The user scrolls back up to the filter controls. They select laptop from the product dropdown, and after a short moment, the dashboard updates. Both the summary cards and the data table reflect only sales records related to laptops. Next, Alice is chosen in the sales rep dropdown. The dashboard responds by further narrowing the dataset, showing only laptop sales attributed to Alice, with all summary and table data updating accordingly. Continuing, the user selects Europe from the region dropdown. The dashboard filters again, now displaying only laptop sales by Alice in Europe. The summary cards and table adjust to represent the refined subset. The user then enters 1,000 into the min revenue input, applying a lower threshold to revenue. The cards and table instantly update to show only high-value sales that meet all current criteria. To refine the results further, the user types repeat in the search bar labeled Product, Rep, Region, Notes. The dashboard instantly filters the dataset, updating the visible rows and summary metrics to match the search term. The user scrolls down to observe how the data table and summary cards have updated in real time to reflect all the applied filters and search. They then scroll back up, locate the clear button, and click it to reset all filters. The dashboard promptly returns to its initial state, showing the full dataset in the summary cards and the table. Next, the user changes the sorting options, selecting revenue in the sort by dropdown and ask in the direction dropdown. The data table reorganizes its rows, now sorted by revenue in ascending order. Scrolling down, the updated table is visible with the new sort applied. The user clicks the Load More Rows button, and the table expands to show additional records, confirming that the dashboard efficiently handles increasing data volume. Returning to the controls, the user filters by Open in the Status dropdown. The data adjusts to show only open records. They then set the max revenue input to 6,000, further limiting the results. The table updates, and if no results match, a No Results Found message appears. Finally, the user resets all filters once again by clicking the Clear button. The dashboard restores the full dataset. The user scrolls slowly through the entire content, observing the smooth updates, responsive filtering, and sorting throughout the experience. You've just unlocked the key to lightning-fast React dashboards without adding a single dependency. By mastering useMemo for filtering and sorting, you eliminate lag, keep interfaces responsive, and ensure your apps scale as your data and user base grow. This single optimization can transform the day-to-day experience of anyone working with complex UIs. helping you deliver professional-grade performance with code that's easy to maintain and extend. If you want to keep building real-world skills that make an immediate impact on your projects and career, subscribe now. Every tutorial here is packed with practical, production-ready patterns you can implement today, so you spend less time searching for solutions and more time building great software.